Okay, hey there, this is Mrs. Wensley coming to you for 8.2 notes. We are working on perimeters of composite figures. Perimeters of composite figures. Composite figures are shapes where we have multiple shapes that make up that figure. So, first thing I want you to do here is put your name right up top. Today's date is May 1st, 2018. Whatever your block number is, my homeroom is going to be 1. Miss Gino's is 2. Miss Mark's is 3. Alright, today's I can statement. I can find perimeters of composite figures. Our central question is, how can you find the perimeter of a composite figure? It's pretty much repeating ourselves. It's the same thing over and over again. So the official definition, what I want you to know about composite figures, is that composite figures are made of triangles, squares, rectangles, semicircles, and other two-dimensional figures. Sorry about that. So composite figures are made of triangles, squares, rectangles, semicircles, and other two-dimensional figures. Something to note here is to find the perimeter of a composite figure, we need to find the distance around the figure. We have to use what we know about these different shapes to discover the perimeters. So the perimeter of a composite figure does not equal the perimeter of the individual figures. Because the composite figure does not include the measure of the shared side. So if we look at example 1 here, the shared side of the triangle and the rectangle is right here. This shared side right here, we do not count. If they were two separate shapes, we would count them. If they were the individual shapes, we would count the perimeter here and the perimeter here, and then that side gets counted twice. However, in a composite figure, we do not do that. So, to estimate the perimeter of this arrow, it's on a grid, so we have to count the total number of square lengths including the ones that are only partially there in the top portion, the triangular. Let's put triangular portion. But we're going to do something special with these because these are actually irrational numbers. So we're going to do something special with these slanted ones. So hang on for that. But just know that we have to count them up. So we're going to count here first, and then we're going to go over here. Go ahead and flip your paper over. So our first direction is to count the number of grid square lengths. So I have an extra copy here. I'm just going to put the picture up in there so that we can look at it while we're doing this. So count the number of square grid lengths. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So for the step 1, counting the number of total square lengths. That's full square lengths that are covered in this figure are 20. And we don't have to do anything special with that. So our perimeter is going to be 20 times 1 square length equals 20 units. Count the number of diagonal lengths around the arrow. One, 2, 3, 4, 5, 6, 7, 8. So we have 8, but that number is irrational. So we have 8 diagonal lengths. We're going to multiply, since it is an irrational number, we're going to multiply it actually by 1.5, not 0.5. So we're going to multiply 8 by 1.5, which will give us 12 units. And then we're going to add up the 20 and 12. So we're going to do 20 plus 12 is about 32 units. So slanted lengths are irrational. Numbers. So this is why we are asked to estimate. So that's another reason why it says estimate or about, because since we have irrational numbers, we cannot figure out the actual. Now go ahead and pause the video and work on the on your own problems. Welcome back. Now we're going to look at example 2. Example 2 here. We are finding the perimeter of a shape with a semicircle. Step 1, we're going to add up the perimeter of the non-semicircular shape. Step 2, we're going to find the perimeter of the semicircular portion. To do this, we need to use the equation for circumference and divide it by 2. We talked about this in 8.1. Alright, so now we're going to look at this one right here, and we're going to follow those steps. So step 1, we need to add the side lengths of the triangle. 8 plus 6, right here and right here, 14 feet. Now we're going to use the circumference equation. And, whoop, missed a letter, then divide it by 2. So our circumference equation is C equals pi times diameter. The other one is also our C equals 2 times pi times radius. But since we have this length right here, this is our diameter. It goes all the way across that circle, or semicircle. So I'm going to use this one. So circumference equals 3.14 times 10. 3.14 times 10 is 31.4. Now remember, we need to divide this by 2. So you should get 15.7 feet. Now down here, we're asked to find the perimeter, and to do so we need to take the two totals and add them together. Therefore the perimeter is 15.7 plus 14.0. 15.7, 14, or 14.0. It's going to be 7. Carry down that decimal. Remember, when we add decimals and when we subtract decimals, that decimal point has to be lined up all the way through. 5 plus 4 is 9. 1 plus 1 is 2. So you get 29.7 feet. And remember that it is about, which those two wavy lines in front of it mean about 29.7 feet. Now if we turn the paper over, we'll look at a similar problem, but we're going to use this model instead. This is a track, because if you were running a track outside, we have the radius of this semicircle, which is 32 meters. We have the side length of the rectangle, which is 100 meters. So the track is made up of a rectangle and two semicircles. We want to find the perimeter. Both of the semicircular ends of the track have the same radius. If they have the same radius, remember that also means that they have the same diameter, because diameter is radius times 2. So 32 times 2, whether it's up here or down here, is going to be the same number. It's going to be 64. And without the rectangle, they make a circle. So we need to find the circumference to find the perimeter of the two semicircular shapes. So, if we're looking for the circumference, since I have the radius, I'm just going to use that. 2 times pi times radius. 2, I'm going to use 3.14 again for pi. Remember, you can use the fraction of 22 over 7 if you would like that and like to use that instead. Excuse me. So right here, I multiplied 3.14 by 2 because according to my PEMDAS, or please excuse my dear Aunt Sally, when we have straight multiplication, we just multiply across like we're reading a book. So we're going to do 2 times 3.14 is 6.28. And I still have that 32, so I'm going to do 6.28 times 32 to get 200.96 meters. The rectangle has two sides. That are the same length. Therefore, it is going to be 100 meters plus 100 meters equals 200 meters. So the perimeter of the track is going to be the circumference plus the sides of the rectangle. The circumference plus the sides of the rectangle. So we're going to do 200 plus 200.96, which is about, so remember we used that 3.14, which is not an exact number, so it's about 400.96 meters. That's the perimeter. Now go ahead and pause the video again and try these two on your own problems. When you finish those, I would like you to continue on to these other problems. Here's 1 through 4. This backside is number 5. But then down here, these ones, please note this. This is an extra credit opportunity. I'm not going to go over these answers with you. I just want to see how much you know. So I want you to go ahead and try that. That is up to 5 points of extra credit. And that is all I've got for you today. If you have any questions or you need to go back over this video, please feel free. Raise your hand if you have any questions. And all the steps are in there for you, so you should know how to do the rest of the extra practice problems that I gave you.